So welcome to the reactive programming in Android Meetup. So just a brief introduction about me. I've been in the industry for around almost 7.5 years, and most of my work has been in mobile domain. Currently, I'm associated with Talentica Software. I joined like 2 years back. I'm also one of the co-organizers for Pune Mobile Developer Meetup group. So during this meetup, I'll be taking some polling. So just honestly answer if whatever you want to answer. So nobody is judging you, so you can answer honestly, right? So reactive programming is actually it's a big concept, and there is a steep learning curve. But once you learn it, so you will see that how easy it will make your lives as a developer, especially as an Android developer. So the more I learn about it, the more I feel that this is a library that should be included by default in even in Hello World projects. So you get the point, right? So I'll consider this meetup a huge success. If you today, when you go out, after this meetup, just try out reactive programming. So okay, oops, sorry. Okay. So how many of you are professional Android developers who develop Android apps for a living? Okay. That is to be expected. This is Android. Okay. And how many of you have heard of reactive programming and implemented it in your projects? Okay, that's good. So this is actually very basics. Plus, we'll be covering some intermediate and advanced concept, but mostly it's basic. And some of the concepts are very generic, not especially related to Android, reactive programming in general. Okay. Okay, so some of you have also done RxJava, right? Has anyone used RxJava 1, the older version of RxJava? You've used it, okay. So it's a significant improvement. Okay. Okay, so let's start. Yeah. So today's agenda is we'll be seeing what is reactive programming and why we should be using it. There are already so many models available out there. Right? So why we should be learning a new model? And then we'll see what is reactive extension. We'll see RxJava and Android. Components of reactive programming. This will be this is the main topic of this meetup. And then we'll see how we can use retrofit with reactive programming in RxJava. And we'll see some of the operators. There are so many operators, I cannot cover everything, but I've covered like some of the operators. And then we'll see how RxJava helps us in testing also. So during this meetup, if you have any questions, you can raise your hand and you can ask the question. You can stop me right there. If you wait till the end, we'll lose the context, and so just ask at the right time at the moment when you get the question. Okay. So reactive programming, Wikipedia definition is it's an asynchronous programming paradigm concerned with data flows and propagation of change. There are some big words here, I know. So in simple words, it's just programming with asynchronous streams of data streams. So it's nothing new. It's always been there. It's just some advanced. We have actually they've modified it a bit. Is everybody familiar with observer pattern? Yeah. So it's like it's a combination of observer pattern and iterator pattern plus some other things. We'll see. So first of all, why do we need asynchronous programming? So I'll explain in terms of Android, because you don't want to block the UI. Blocking the UI is evil. When you block the UI, especially in an Android application, what happens? You get this. Right? I hope everybody has seen this in your apps that you developed.
I've seen it on Facebook as well.
Okay. Probably problem with your phone. When this happens, then what happens? Right? You have sad users, and when the users are sad, this is what they do, right? I've seen this types of. these types of reviews. There are so many. So, okay, I made up the first one, but the rest are real. Okay, so now that we know why we need asynchronous programming, so now it will make some sense because we don't want to block the UI. Asynchronous programming means simultaneous operations, right? You don't want to queue the operation so that one finishes and you do something else. So asynchronous is like you are doing multiple operations at the same time, and as soon as the operation finishes, you will get some sort of callback so that you can code accordingly. Okay, so is there anyone who doesn't know who's Jake Wharton? So if you don't know Jake Wharton, then you're probably a new Android developer, newbie, or you're lying about being an Android developer. Trust me. So this is, I took this idea from one of his talks, which, by the way, you should all watch. Has anybody seen this talk? DevOps 2017? You have seen that. Okay. So consider this a simple interface. It has three methods: get user, set name, and set age. So the complexity arises when these are, say, asynchronous. These are updating some remote database. So what we do is we cannot just call these methods like this because we want to know if some error happens or it succeeded or not. If some error happens, so we can take some actions accordingly, right? So we want some sort of callback. So this is the popular way to do it. Like this is a standard Java way to do it. You add some listeners, and the listeners will tell you if the callback succeeded or it failed, right? Yeah. Any questions? So now when you try to use user manager to set a name, right, you'll do this. You'll pass the name that you want to set. You get user manager from some say factory method, or you create like a retrofit API, and then you'll pass the callback, success and failure. So if some failure happens, could be like a network failure or could be 404 or whatever failure is there, it will report here in the on failure method. And success, it will return the same user instance. The user instance from the remote database. Now, if you want to do set age also, so now this becomes complex. This start becoming complex, right? All I want to do is set name and set age, and now I have to deal with 4 cases. And there could be like, if you mix and match, there will be so many complex cases for simple operations. And it becomes more complex when you try to, execute this operation one after the other, because the output from one API is dependent on the other. Then you'll put this entire thing inside the on success of this, because I want this to execute only when set name succeeds. So right, I'll put it there, like this. So this, I don't know if you've heard of the term or not, this starts becoming callback hell. This one callback, this is second callback, and if I want to do something else that is based on the result of this callback, there will be third level of callback. In one of the apps that I worked on, believe it or not, there was 10 levels of nested callbacks. 10 levels. It was going out of the page. You cannot see it in one screen. So this is actually, so this is not the end of the story. Now, based on the API call that we're doing, right? Based on the result, we want to, let's say, update the UI. I want to update a text view, or just update some UI that, okay, you have logged in, or your name is set, right? So I'll do this text view inside the on success of this. Just set the value, set the username in that text view. The problem is, by this time we don't know if the activity is alive or not. So we have to add a check if destroyed. If the activity is destroyed and you try to do this, what will happen? It will crash that. It will crash the application. Excuse me. So we'll put this check. And plus, there is another problem. Let's say set name is called, it got succeeded. Then set age, we're calling set age, and it's taking some, say, 10 seconds to complete the operation. And after 10 seconds, if it succeeds, we'll update the UI. So before, let's say as soon as the set age, this API starts to do its thing, the asynchronous thing, and you close the activity, there is a short-term memory leak here, because the activity is destroyed and you're still holding some reference of that activity. So there is a short-term memory leak. We don't want that memory leak to happen, right? And plus, since we have not specified any threads here, and you cannot update a UI from a background thread, right? You need to pass the data to a UI thread, and then you have to update it. So we'll need to do this. You'll need to pass everything in the run on UI thread method, right? So now, yeah, just look at this. It's becoming callback hell for fairly simple operation. So this is where reactive programming excels. Uh, it's a it's a library for dealing with asynchronous streams of data. So reactive programming is basically a combination of observer pattern plus iterator pattern and plus some functional support. So is there anyone who has only worked in Java, not in Kotlin or JavaScript or Swift or only Java? Okay. So then you will find functional support very important. Okay. So it's a combination of all these. I wanted to write functional programming here, but it's not functional programming, because if you write functional programming here, so it starts becoming functional reactive programming, which is which is not the topic of today's meetup. So just some functional supports, and this is not the end of the story. There's more to it. It provides concurrency, plus resilience, plus it enhances readability, and this is not the end of the story. Right? It's a reactive programming meetup, so I should be saying good things about reactive programming. But even if this was not a reactive programming meetup, and you had asked me somewhere, right? I'll say that I'll say all these things either way. So observer pattern, if you're not familiar with it, what it does is there's a subscriber, there's a source of data, and it emits some data. And there are subscribers, or you can call it observers, and they subscribe with the source. And after subscription, whenever the source emits the data, they receive it. So this guy probably subscribed earlier, so it has more data than lesser number of data. So, and if the subscribers, if they don't want the data, they can unsubscribe with the source, and the data won't be propagated to the subscribers. Now, this is a standard observer pattern that was brought in by the Gang of Four. But this observer pattern has some issues, two issues to be specific. One issue is there is no way for the observer, the source. Okay, when I say observer, it's the one who's observing and receiving the data, and observable or source is the one that is emitting the data or sending the data. So there is no way for the source to inform the subscribers or observers that, okay, I'm done, I don't have any more data. It cannot say, okay, I'm complete. There's no completion handler. There's no completion event in observer pattern. And if some error happened here, there is some error because of something, maybe could be anything. There is no way there is no way for the source to propagate the error to the subscribers. So reactive programming fixes this gap. It bridges this gap. Iterator pattern, in this, what happens is there's a list of items or objects or values, right? And there's a consumer who wants to consume the values. So iterator pattern allows us to iterate over the entire list of items sequentially without worrying about the actual data structure that is used. It could be an array or an array list, it could be a file or tree, or it could be anything. So it's because it's an abstraction. So the whoever is consuming it, it will just say, do you have any more values? If yes, okay, just give me the next value. And you can consume the entire data. You can iterate over this data. And functional support. So this is one thing that is missing from Java. Java 7 had very limited support, right? Java 8 has some support. There are lambdas and method references. So what happens is there is an iterable, right? Like there is a error list. So you want to iterate over it. We can iterate. So now if you combine these two, observer pattern tells you that maybe right now I don't have all the data. I may have some data in the future, right? An iterator pattern, using this, what we can do is you have a list of data already available. There's no future here. And you can iterate over the items. So you combine this, data will be coming with time, and you can operate. You can use some functional operators on this data. So functional programming. I mean, if you don't know about it, right? So you should probably see this functional programming thing. It's If you see look at the modern languages like Kotlin and Swift and any modern language for that matter, right? So they all have functional support, some sort of functional support. And since Java 8 also introduced functional support. Excuse me. Reactive extension is a library for composing asynchronous events. So if you want to know about who came up with reactive programming and all, maybe you can look it up. I don't have it in my slides. But yeah, Microsoft came up with reactive programming, and Eric Meyer from Microsoft. This is a reactive extension is a library for composing asynchronous and events-based programs using observable sequence. So let's see some of the big words here. So there are a few big words like asynchronous, event-based, and observable. So asynchronous, we already know what is this. Event-based, it performs some operations when the event is triggered, or based on some event, we can perform some operation. And observable, so you can think of it as asynchronous immutable array. Asynchronous because in an array, it's all the values of the array is not here completely. The values will come with time. And so asynchronous, and immutable because you cannot change it. Not exactly array, it could be list also, or it could be a single item also. So reactive extension, it's available for, okay, you can see for yourself, right? You pick the language, it's available there. From C#, Unity, Java. Any Kotlin fans here? Kotlin? Oh, come on, you should start using Kotlin, man. Swift, JavaScript, Scala, Python, Clojure, C++, Groovy, Go language. So you name it, reactive extension is there. It's still, a lot of active development is still going on, so we can expect support for more languages soon. So yeah, there's no Android here, right? There's no Android. Where's the Android here? There's no Android. So we use RxJava and Kotlin, if you are Kotlin with RxJava, to implement reactive programming in Android. So RxJava is a JVM implementation of ReactiveX, and RxAndroid provides whatever is missing from RxJava, the Android specific things, so we can use it with Android app development. So from the official documentation, what it says is, you include RxAndroid in your Gradle dependency with the RxJava. Yeah, please come. With RxJava. So because RxAndroid releases are very few, and RxJava releases are quite a lot, and there are some bug fixes, and also you should use both of these together if you want to use reactive programming in Android. There are a lot of big names about who's using Rx. Okay, so let's see some of the components of reactive programming. So there are basically three major components of reactive programming. One is source, of course, something that emits data, and this data, it can be passed around between threads, or it can be consumed directly. And there is a subscriber. Subscriber is the one who consumes the data that is emitted from the source. And there is a scheduler. So these are the three S of reactive programming. Scheduler, it deals with threads and concurrency, and it tells us where to process and consume the data. So yeah, these three are the major components. If you look at it once in one go, like it looks complex, so we'll break it down. But basically, there is a scheduler, there is a source, and there is a subscriber. So let's break it down. So source will get some data from somewhere. It could be from network, database, files. It could be any operation. It could be user touch event or a drag event, XY coordinates. It could be from anywhere. So we'll not worry about where the data is coming from right now. And this is the timeline. And source, what it does is it emits the data. And you remember in observer pattern when I was talking about there are two gaps in observer pattern, right? Uh, observer has not observer. I mean observable or source has no way of telling the subscriber that okay, I'm exhausted. I don't have any more data. So it's there. So if there is an error or the data is exhausted, the observable or the source can inform all the subscriber, okay, I don't have any more data. So maybe you can do on to some other processing. And these are called exactly once. Once some error happens, it will not call on next after that. When on complete happens, it will not call on next after that. On next is how we pass the data. So here we are assuming the data is some integers 1, 2, 3, right? So okay, now it just doesn't just emit the data. It depends on the type of source or observable you're creating. But the idea is there is a subscriber. So subscriber, what it does is it will subscribe first. It will subscribe to the source. Okay, I'm ready to receive data. And after subscription, whenever this source emits the data, observer receives it, and observer can update the UI or local DB. So this is a different way. Based on the data, the observer can perform some operations. And when the let's say subscriber doesn't want any more data, it could be in between, it could be at any point of time, right? In any point of this timeline. So when the subscriber doesn't want any more data, subscriber can say, okay, dispose. So in RxJava, or probably I think somebody has used RxJava. So in RxJava 1, this was unsubscribe. So this was subscription interface. So that's been changed to dispose in RxJava 2. So dispose means this is a way to cancel the operation. So let's say there is an observable which is doing some network request, takes 10 seconds, returns me some data, and meanwhile, I close the activity. User closes the activity in one of the slides that we saw, right? So user closes the activity. This operation is going on, right? So what we can do is we can call dispose, and the operation gets cancelled. So we get some extra resources to use, right? And how scheduler fits here is, before that, this adds one level of abstraction, right? Because this guy, the subscriber, doesn't care where the data is coming from. It's just getting a sequence of data from observable. And now where this guy gets it from is where we actually need to deal with databases or REST APIs or remote databases. Now where scheduler fits in this picture, let's see about that. So scheduler is, what it does is it parameterizes concurrency. So how many of you have done this? Just raise the hand if you've done this. Okay, everybody has done this, right? So if you have used Kotlin, okay, I know most of you have not used the Kotlin, but if you've used Kotlin, so there are things like coroutines. There are coroutines, right, which helps you, which are basically cheaper threads, which we are in full control of, unlike actual threads which OS controls. If you have done iOS development, so there is something called GCD there, Grand Central Dispatch. It allows you to, it abstracts the concept of low-level threading, and it allows you to perform asynchronous non-blocking IO operations in a very simple way. Is anyone aware of any threading libraries in Java or in Android that we use? I don't know. I'm not aware. It's probably there, but I'm not aware of it. So here, the modern programming languages, if you see, each of these programming languages, they have some sort of support for handling low-level threading. So you don't have to deal with creating threads and dealing with this thread management and synchronization. I mean, what can I say? I'm allergic to it, actually, seriously. So pretty soon in like meetups like this, people will be saying cavemen used to do thread equal to new thread. Because now there are some sort of wrapper available everywhere in all the modern programming languages, right? So schedulers is what allows us to do this. It allows us to deal with threading, concurrency, synchronization, concurrent data structure. Oh yeah, that was out of time. So you can abstract away these things. So it's kind of like I don't have to deal with synchronization. This is one big part of when you write apps or or applications for that matter of fact, right? we don't have to deal with threading or synchronization or thread safety or concurrent data structure. uh, RxJava will help you with this. Now, RxJava is not magic, it was not created by Dumbledore. So if you use it, it's not like your app will magically becomes great. So you have to learn it. There's some steep learning curve, as I mentioned earlier. Yeah, but uh, if you use it properly, you will see more happy users. And all you need to do is it provides some factory methods. So if you want to do some IO operation, you can call schedulers.io.computation. So if you have some computation related task. If you have to create a new thread anyway, you can just call new thread. Or if you want to, you want control over how many number of threads that gets created. It is optimized, by the way, for the based on the device and the number of cores available. But if you want to control over it, you can create your own executor. Thread pooling, if you have done, you can create your own executor and you can create schedulers from there. Now schedulers, so it fits there. So we can decide where it's getting the data from. If it's getting data from network, it should probably be in this IO thread because it's a blocking operation and we don't want to block it. When we are updating the UI, this should happen in the main thread, right? We cannot update from the background thread. So these are the three main components of reactive programming. Yeah.
Can we not do this with the help of event buses?
Yeah, we can. So event buses are there. Event buses will not do with scheduling. And yeah, I have these questions after some slides.
Lots of boilerplate are there.
Yeah, a lot of boilerplate there, and you have to deal with a lot of things there. So we'll see. So RxJava2, there are some core types. So these are generic terms like source and subscriber and scheduler. So we'll see RxJava specific types. So these are some of the RxJava specific types. There is observer, which observes the data. For creating source, there is disposable, consumer. These are like some of the main types. This is not all. Once you start dealing with RxJava, there are more types that you can use. So we'll see what each of these are. Observer is something that the subscriber, the third S, the second S, the subscriber, it receives data in the on next callback, in the on error callback, in the on completed. If the source is exhausted the data, it will call on completed, and it gives you a disposable. So this disposable you can use to cancel the flow, and or to know that if somebody is still subscribed or not. This is X source because there are various types of sources in RxJava. There is observable, there is single, there is flowable. So this X you can replace with this will become observable source, or flowable source, or single source. So I've just whatever is written here is only for observable source. So multi-valued reactive abstract class. It could have multi values, and it will emit the values in an orderly fashion in the on next call of this, which is received in on next call of this. So what it does is you can create this. If you want to create from scratch, you want to decide what's going to happen, you can use this. And there is it takes a parameter when you try to create it using factory method create. It takes a parameter which is observable on subscribe for observable, single on subscribe for single, or flowable on subscribe for flowable, which has this on subscribe parameter, and it gives you an object of an emitter. So where we are in full control of when we'll call on next or on complete, or if some error happens, we'll call on error. We are in full control of that using this. So apart from this, there are many factory methods. We'll see some of them soon. And then there is disposable. It has like these two main methods: is disposed or disposed. So before sending some data, it's probably a good idea to see if it's disposed. The subscriber is disposed. So using this, you can unsubscribe from the source and cancel if any flow that is in progress. Consumer is functional interface that accepts a single value. So for side effects like do on next, that we'll see later, or error, so things like that. So in their consumer is used. It will just take one generic value. So this is X emitter, so it could be like observable emitter for observable, flowable emitter for flowable. And using emitter we can call on next. These methods are available for us. So we can decide which value to pass, we can decide when to throw error, what is my error condition, and when the say all the data is done on complete. Transformer is the interface for composing sources. I'll show you a great example of transformers in one of the samples that I've created. It has, you can see, like, it will take one parameter, it will take observable of one type, observable T, it will convert it into observable R, a different type of observable. And there are then schedulers, we have already seen this, parameterized concurrency. This is some advanced reactive concept subject. So this is something that can act as both an observable as a subscriber and a source, an observable and a observer. So we'll not be covering this, but if you have any questions, maybe we can ask after the session. So you have to use it with caution. So if you see this, the source code for this subject class, right? So subject class, it extends from observable abstract class and it implements the subscriber interface, the observer interface. So it connects as both. And if you use this properly, it can ease out like some of the pain in your application. But yeah, most of the times what happens is you don't have to worry about subject and all, right? If you want to just start using RxJava and Android applications, just look at this first 2-3 types and you're good to go. You can start. And by the way, that is the best way to learn RxJava. I actually, when I started it, I was going through the theories and I looked at, I don't know, like 50 blogs and some videos, Jake Wharton videos and other videos that had less than 20 views. I've seen that also. And then once I started learning this. I knew all the theory, but I did not know how to implement it. So once I started it, right, I got this observer creation wrong like 20 times. After that, I got a hang of it, and now I can use it. So this source, we'll talk about like what are some of the sources available in RxJava. See, these are the sources available in RxJava. This is observable, which emits, it can emit 0 value or 1 value or n number of values, and it will finish with OnComplete, or it could emit infinite values also. There is flowable, single, maybe, and completable. So observable, it emits 0 to n items, and it terminates with success or exception. So it's also possible that without emitting a single value, there was an error, and it will terminate with exception. It's also possible. Flowable is exactly the same as observable, but it supports back pressure. This is also back pressure is also one of the advanced concepts. You'll probably not be using it, but back pressure is something when let's say there is a source which is emitting data at an extremely rapid pace, and you cannot process the data as fast as the source is producing them. Like for example, a drag event, you have a paint application, like user is dragging, user is drawing something, a kitten meme user is drawing. So there are too many x and y coordinates variables, and you want to, as soon as you get the data, you want to process it, then you want to update the canvas, right? So there is a lot of things going on here. So if you are not able to handle this, if your subscriber is not able to handle the data as fast as the source is emitting it, so back pressure helps there. So what it does is, it will not solve actually the issue, but what it will do is, it will defer the processing of some data to some point of time where it's actually suitable for it. So there are some back pressure strategies, like you can drop some data, you can use some buffer, you can increase the buffer size. So if you are dealing with some situation where the data emission is too fast, you can use Flowable. Yeah, by the way, another reason to use reactive programming is if you know about Android architecture components, it's compatible with this observable and flowable types. Single, as the name suggests, right? It emits a single item or an error. it has no completion indicator. So only success or failure. Maybe. Maybe what do you know about optionals? Like in Kotlin, there are nullable types. Right? You put a question mark at them, and in Swift there are optionals. It also has a question mark at the end. So what it says is, if there is some variable which is an optional integer or an optional string, so it means it can contain a string. It can contain null also. It's a nullable type. It can contain null or a string. When you think about maybe, is the same. It can contain null or the actual value, but not right now. We're talking about reactive here, right? So asynchronous, but not right now. Some point in the future. So you can describe it as reactive optional. It's a reactive form of optional. Right now, we don't know if it contains a value or not, but in the future, it may contain a value or it may contain an error or null. And that's completable. We can use this type of source when all we want is, just success or failure. We don't care about the response type and all. So, and that time we can use completable. Any questions still here? Okay. So there was a lot to take in. There is more to come in. Okay. So I have one question now. What you were asking. Okay. So how many of you think this is true? This reactive programming or source and subscriber, it's just a slight extension of observer pattern, nothing more. Okay, come on. I said be honest. So we have seen some things like scheduling is not there. So we already know about a lot of things, right, which will help us in actual development of this. The real power actually comes with reactive extensions, where we have operators that can actually allows us to transform, combine, and manipulate, and work with sequences of emitted items. That is where the real power comes, and that we'll see in the coming slides. Now, how to create observables? Creating observables, there are some methods here to create observables. If you want full control, use create. Or if you, for testing purpose, like this is excellent for testing purpose. If you're testing it, so let's say you have some sort of observable that is getting data from the network, and it's updating the UI. Now, if you want to test it, you don't want network dependency, right? So you can use this methods because essentially it's an observable of integer or observable of some type. So we can use operators like this to create observables. Create observables from scratch. So where we will be deciding when to call on next, when to call on error or on complete. Differ will actually, it will create a fresh observable for each subscriber, and it will defer the creation until at least one of the observers subscribes. And this I don't know where you'll use this, probably just for testing purposes, but as the name suggests, this will create an observable that emits nothing but completes normally. Never will create an observer which emits nothing, but it will never terminate. An error is something which will terminate with an error. It will not call on complete. It will call on error. And from its if you have say a list or any list data structure, list or data structure, you can use from. So you can create observables from a list of items or from an array or from a flowable, from a different types. You can create the observable. Interval is, it just emits a sequence of integers in the specified interval. It will not call on complete. So we've seen this. Now these are some factory methods. The rest of the factory methods, let's see that. So if you have just one value, right, let's say string s is equal to John, you can create an observable with just that one string. If you can just call observable.just and you pass it. I will show you in demo some of these. Range, when you want to create a sequence of sequence of integers, a list of integers in a particular range. Say 1 to 120. Repeat. It will repeat it. It will repeat the observables for a particular number of times. this, I'm not sure if it's available in RxJava or not. But create an observable that returns a value from a function. Timer, it will, after some delay, it will emit the value of the observable. Now this is where things get interesting. Transforming observable. Okay, before this, is anyone who's not aware of MVP pattern? No, honestly, I mean, nobody's judging you, so okay, everybody's aware, so good. So in MVP pattern, what happens is there is a view, there is a presenter, and there is data, model node. So it's called MVP model. View interacts with the presenter, and this interacts with the data. And the job of the presenter is to get the data and update the view. And what view does is, if there is some events happening here, it will pass it to presenter, and presenter will take some actions accordingly. So this interaction is not direct; it's actually they talk via interfaces. So it's more abstract. So now I'll tell you in this. I created one demo app. I'll show you. So what I wanted was this demo app. What it does is it talks to some third parties, and it gets images from, let's say I have an account in Facebook. Right? It will get my Facebook images, or Flickr. It will get my Flickr images, or there is imager.com site. So it will get the images from there, and it will show all the images in a single page. So now the problem is, I have to get images from Flickr or this, or maybe Facebook. So now all of these, they have different types of structures. The image structure, the metadata for the image, this has some different structure, this has different structure, this has different structure. I don't want these structures to be propagated here. Because tomorrow if this API changes or Facebook changes the API, I don't want any changes to be here. I want this to remain independent of that. So as soon as the data comes in, so I got like A type of data, let's say a list of A, list of B, list of C. I want to convert this into a list of, say, this is my type that I'm using it. I want to convert this list into this, and then I want to update it. So this is independent of this. Only this the model class is dealing with this, right? So now with this in mind, we can go ahead with this. So a lot of Android developers, what they do is they think that model is just the Java model class. No, it's not just the model class, Pojo class. No, it's much more than that. It deals with your entire data, where to get the data from, local database or APIs, all the API calls, everything is included here. And if you're properly using MVP, there should be no Android dependent component here, no context, no Android dependent component here. So it eases up the testing. So why people are using MVP pattern is because you want to test the view. You can mock this part. You can mock this part, and you can test it easily. You want to mock this. You can mock the model. You can test the presenter and view. Okay, so now let's see this. These are transformational operators. It will transform the type of data. It will transform the the observable itself. So buffer, flat map, group by, map, scan, window. There is more. Okay, there's one more merge. I have not written it here. So there's more. You can see it. You can read about it. And by the way, there is reactivex.io is a great source for reading all this. Its documentation is great. So buffer, what it does is, this is the timeline. This is the timeline of the input observable. This is the timeline of the output observable. And what buffer does is, if I specify a buffer size of 3, in this example, I've specified the buffer size of 3. So now, the observable, that is the output, right? It will give you a list of items when the buffer is full. So first item received, it will not emit anything. Second item received, it will not emit anything. Third item received, now the buffer is full. Now it will emit a list of these 3 items. The same goes on. So, and one more thing here, whenever you see this dash, right? This is the on complete event, and when you see a cross, that's a on error event. And these are taken from RX Marbles, another good site for learning reactive via this colorful diagram. So this is buffer. So you can one great example I can think of with buffer is for this. Now this contains 50 images. This contains 70. This contains 20. We don't know how many. Could be like this. Total of 120 images. Now these 120 images, right? We don't want to load everything here. We want to apply pagination. So I'll use a buffer. I'll use a buffer with, let's say, pagination of with a buffer size of 10. So you receive 10 images, you give it to me. You receive 10 images, then you give it to me. You can do that. Flat map. What it does is it will map to each item of the input observable, and it will create an observable out of each input item. And so there are, let's say, if there are 20 items, there will be 20 observables, and then it will flatten it. It will take all the values, and it will convert into one observable, and it will emit the values accordingly. So the resultant output is just one observable. This example I will show you in group by is when you just want to group the observables. So flat map, I'll show you the example later. Group by, we can think of it as there is an institution, there is a college. Now college has housekeeping staff, professors, deans, registrar staff, students, a lot of people, right? So now let's say we are getting the details of all these people, and we want to just group it. So we want to say if it's student, put it in student group. If it's a registrar or dean or professor, put it in professor group. If we can create group, and so what group by will do is it will give you this. It will group the emitted items, and you can use these emitted items. Map, it's easy. This is one of the higher order functions. It will apply some sort of transformation in the input observable, and then after applying the transformation, it will emit those items. Has anyone used maps in Kotlin? In JavaScript, in Swift, right? So you can do that, but you do it with iterables, the static types, or not the static, the synchronous types. We can do map with asynchronous types also. Scan, what it does is it successively it gives you the successive value. So now it emits 1, it will emit 1. It emits 2. Input observable emits 2. So it will add these 2. 1 plus 2 is 3. It will emit 3. Next is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. It will emit successively for each value. In some cases, it can be very helpful. There is window. What window does is, does it look similar to buffer? Right? It's creating a batches of 3 and it's emitting it. It's actually very similar to buffer. The only difference is buffer, if you see, it's also creating a batches of 3 based on the buffer size, and it's emitting. It emits a list of values. It will be a list of string, integer, or any data type for that matter. And this window, it will emit actual observable. So when you do this, you input one observable, you can output like n number of observables. So now that since we know about asynchronous programming, we know about how to create the observables, the source, and we know about how to transform the operators. Sometimes what happens, you want to filter it also, and these are like different use cases. So filtering operators, there are many. This should not take long because the names are self-explanatory here. So you can filter the values emitted by an observable. So distinct will, of course, it will give you distinct values. So there are 2 2s, it will emit 1 2. There's 1 that was emitted earlier, it will not emit the 1. 3 is distinct, it will emit the distinct values. So this is also, in a way, if you see, this is not actually transforming the observable, it is just filtering out some of the data. Element add, it will give you one observable, whichever is the position, past position, and it will call onComplete. You see this dash, that's onComplete. filter based on some condition. The condition here is greater than 10, so it will only emit greater than 10 values. You can filter it out. You can take the first value. You can take the last value. You can skip some initial values if you want. If you want to take some, just some first, let's say n values, you can write this. You can use take. It will take just the specified number of values. It will call on complete. Take last from last. Just it will take this last value. If you pass 1, if you pass 20, it will take last 20 values. This, if you think about practical purposes of reactive programming, right? You will be using this a lot of times. So there are going to be things like I have some. That's this example, right? There are photos. The user opens the app. I want to show photos. So now I could have one observable. That is reading from my local database. I could have another observable that is getting the photos from the actual APIs. There could be two observables. Now we want to use this more than one observable in conjunction with each other. So now these are the combining observables. These are the ways to combine observables. We have the operators that helps us in combining observables. So CombineLatest, what it will do is it will take the latest from the observable 1 and the latest from observable 2, and it will emit the combined value based on the condition you've written. It could be if x is greater than y, or any condition if you've written. So now when 1 was emitted, there was no value emitted from the second observable. So it will not emit 1. So as soon as it got this, it will combine these two based on x plus y. 1a it will write, 1a it will emit. Now when 2 comes, what is the latest of observable b? A. Because b has not been emitted yet. It's at the later point of time. So it will combine with this, it will emit this. So similarly to b, when c comes, the latest one is 2 from observable 1. So it will say 2c, 2d. When 3 comes, the latest here is d. So 3d, 4d, 5d, because there is nothing after d here. So you can combine multiple observables also. You can start with, so this start with is, you can start with a single value, or start with an array, or start with another observable. You can, you can use all these things with start with. There is zip. What it does is it combines end-to-end thing. End-to-end means, first value from here, combine it. First value from observable 1, second value from observable 2, it will combine it. Nth value from observable 1, nth value from observable 2, it will combine it. So first value is 1a, second 2b. C got emitted a lot earlier than 3, but since these are the third items, it will emit 3c, 4d. For fifth, there is no match; it will not emit fifth. Concat is when you want to emit all the values of observable 1. You want to emit all the values of observable 1, and once that is finished, you want to emit the values of observable 2. So 1, 1, 1. When this got finished, it will emit the second observable, and it will call on complete. It will not call on complete in between, because once on complete gets called, it's essentially the end of the observable sequences. Right? Merge, it will emit, as you can see, right? As and when there is an emission happen, it will emit that directly. So a good thing with all of this observable is all of these operators is they essentially they return the same type of observable, same or similar type of observable based on if you're performing transformational, it will return a different type of observable. So you can change these operators. You can change these operators easily. So now, think of it as like different observables. There is one observable which emits apple, another emits oranges, third emits bananas, and fourth emits strawberries. Now I can call merge operator. You've seen this merge, right? This is the merge operator. So now I can call this merge operator. So as soon as any emission happens in any of these, it will emit that item. So now it will merge all this into a single observable, which is emitting all types of fruits now. Apple, oranges, bananas, and strawberry. Now map. Map is it's like you are not happy with the data. You got the data, but you're not happy with the data. So you want to transform the data. Okay, I'm sorry that came out wrong. Data is not about happiness. You want to say massage the data, right? You want to change the data in the way you want. So, well, actually, data is happiness, right? Data is happiness. I think so. So you want to convert the data from one input type to another type, and yeah, map helps you do that. It will perform certain operation in all the items emitted by some observable. So and filter, I don't like strawberries, so it's filtered out strawberry. So this is filter. We are filtering out items. We've already seen this. I'm just showing you how to combine these operations, how to chain these operations. So now, once you get this, oh yeah, this is the previous one. You got filter. Filter we already seen, and then we can reduce it. Reduce, I've not shown you in the slides, but what it does is, it takes in a list of values, and it will emit essentially just one value. And that one value, since we're talking about reactive, that one value will be, it will be a maybe. It will be a maybe because right now we don't have any value, but we may have some value in the future. So now you reduce it in the way you want. Right? So you get what? Fruit salad. There's an old saying, right? If life gives you observable of fruits, create fruit salad.
So the question is, so
Yeah.
suppose we are doing a multi operation.
Yeah.
I have observable of one type and then I take an observable of two type of the second type and I merge it. What is the resultant type of the?
So initially, like if you have two different type of observables, it will not allow you to merge it. Or you can actually, you can do what? You can apply map, or you can compose. You can with map you can actually transform the type of observable, right? Transform it in the similar type, and then you can merge it. Or you can use the object class in Java. Okay, so we'll see retrofit later. I'll time for some demos. So buffer I want to show first. So what it does is, I'll show you the code. So now there is a buffer of size 5. Can you all see this, or should I increase the font? I think I increased the font. Yeah. Okay, so there is a buffer size of 5. So the emission is happening 1, 2, 3, 4, 5, but it's emitting the value only after the buffer is full in the batches of 5. And in the last example, if you see, the batch is not completed. The 5 limit is not reached yet, but it is emitting this because onComplete got called. So let's see this. Yeah, so it is emitting. If you see, I'm using, so whatever we just read, right, from creational to combining observables to transforming it, filtering it. This will, this is the demo for all that. So it's from array. It's creating an observable from a list of an array of integers, and yeah, there's a buffer here. So buffer we've added. So this is transforming is observable, and do one next. These are what I'm doing is whenever this is received. So this integer, this is essentially a list of integers. If some of these code look like non-Java code to you, that's because it uses lambda functions and it uses lambdas and method references of Java 8. So it's just makes the code more concise. That's it. OnComplete will not written here. Here. On next, this I wanted to test, like, there is a subscribe happening here. Okay, so from the start I'll show you. There is an observable list of integers. Okay, this is a source. We are creating. This is the source now. We have decided which values will be emitted in batches of what, because using buffer. So now here we are subscribing on. Yeah, this is schedulers. This I didn't show you. Schedulers.io. So this will perform the operations in the background thread, in IO thread. And then what we're doing is in onNext, whenever it calls onNext, I'm just printing it out. It's a list of integers. I'm printing out the integers. And here what is happening is we are actually calling subscribe, and we are passing the observer here. So this is the onComplete here. And it's up to you actually. You want to use onComplete here, you can call it here. Yeah, you can call it here. So I've not called it here, and yeah, see, there's no onComplete printed anywhere because we have not used onComplete. But if we do this, do onComplete. So it will print buffer complete. I don't know if you can see or not. Excuse me. So onComplete you can write with subscriber, with the observer here, or when you call the subscribe method, if you see this returns, okay, this doesn't return anything, it's a void. So you get a disposable in onSubscribe, but if you're calling onSubscribe with a consumer, it will return you a disposable. So you can use that disposable. And in the buffer, essentially, you can write onComplete operation here, or with observer if you're using this interface has an onComplete here. When some error happens, it will give you a callback here. So this is buffer. What else? There's one more thing that I failed to mention, that is observables or sources. There are two types. There is hot observables, there is cold observables. So what cold observables do is they will start emitting the value as soon as there is at least one subscriber. One guy subscribe, it will start emitting the value. Second guy subscribe, it gets the values. Hot observable is, it doesn't care. It doesn't care if anybody is listening or not. It's still shouting. It will still shout. It will keep emitting the values. So let me show you the hot observable demo. So this is the first observable. It's printing 4578, and the second observable comes into the picture. It starts printing after some point of time. So you can see the first observable. It is printing after. It is printing first some values because it subscribed earlier, and the second observable, when it subscribed, it started receiving values after some time. Yeah, so I'm using interval here to create the observable. So interval in a period of half second, 500 milliseconds. And as and when you call connect, it will start emitting values. So it doesn't matter. This is basically a publisher. So what happens is, as and when you call connect, it will start emitting the values. So it doesn't matter if you subscribed earlier or later, at what point of time. When you call connect, it will start emitting the values. And where is subscription happening? Yeah, here. So this is the first subscriber. I'm just calling subscribe on this, do on next, and subscribe. Right. So this is the first subscriber, and after a wait period of 2 seconds, there is a second subscriber. So if you look at this, and there is an initial wait, I guess, yeah, initial wait of 2 seconds. So for 2 seconds, since it's a half second emission, so the values, and it called connect. So initial 4 values it will emit, right, in the first 2 seconds. These are not captured anywhere. But a subscriber comes into picture after 4 seconds. So 0, 1, 2, 3, 4 happened. 0, 1, 2, 3 happened. On 4 onwards, this guy got subscribed and it started receiving values. After the next 2 seconds, this guy got subscribed and started receiving the values. So this is a hot observable. Next, let's see map filter reduce. Yeah.
The dual next nothing is a hot observable.
The
Hot observable.
hot observable, okay. Yeah.
Can you write dual next instead of subscriber directly into observer after the connect?
After the connect?
Yeah, because dual next there is a two like on next and dual next.
There is duo next is actually on next.
Yeah, but it will emit first and after the on next will be.
No, on next is on next is for emitters. Emitter will call on next, and that the value that is passed in on next is received in do on next. Or if you're writing observer or observer interface, if you're dealing with, there is on next there. There's a method itself. Yeah, map filter reduce. Let's see what this does.
So by default they are cold or hot?
By default, they're cold. Yeah, so it emitted some values, and it called onComplete, and we are reducing it. So reduce function is just add the values. So 6 plus 3 9, 9 plus 9 is 18. Okay, so now this is observable using the dot range operator to create the observable. In this, what happens is it's creating an observable from 1 till 20. The count is 20, right? So now this observable, it contains integers from 1 to 20. Now here, if you see, subscribe on schedules of computation. So do this in the background thread, in the computation thread. And then I'm mapping it integer with 3. This is another function. So it is what it will do is it will multiply 3 with all the items of the source. So after this we have like a table of 3, right? We'll have 3, 6, 9 multiples of 3 till 60 because 20 into 3 is 60. So this is map, and then I'm filtering it after map is done. So after multiplication of 3 is done, I'm filtering it. So just filter it out and give me everything that is less than 10. And yeah, this is a subscription is happening when the next value is received. I'm printing the value. When onComplete is received, I'm just printing complete. And this is a reducer function. What it does is it takes 2 values and it's adding the values. So if there are like 20 values, it will give you. It will keep adding it. This is how you write a reducer function, by the way. And on the success of the reducer function, if you see this reduce, right? Yeah, see, it returns maybe. It will not return an observable. It returns maybe. Because it essentially it will just emit one value, and the reactive optional that we know of is maybe. And when this on reduce, this maybe succeeds. What we're doing is we're just printing the reduced value. So now if you look at this will make some sense. So now we had 1 to 20, multiplied 3 with all the integers, so it became 3, 6, 9, 12, 15. Now I filtered it with everything less than 10, so it gave me 3, 6, 9. And the reducer, what it's doing is it's adding it up and it's giving me 18. So, and if you look at this thing, I mean, this is, this increases readability. This is awesome. I mean, I can read this code in one go and I can understand what it's doing. Do something on the computation thread. Do what? With the source we have, multiply, convert it, transform it by multiplying 3, then filter it, then I can call reduce right here. So I can change it, so it increases readability like anything. So that was map filter reduce. Scan is, again, it's simple. It will just give you successive values. So 10 plus 20 is 30, 30 plus 30 is 60, 60 plus 40 is 100, 100 plus 50 is 150. Yeah. So it has, initially the source is an observable that has 1 to 5. I'm using a just operator here This is very handy when creating observables. And then mapping it, multiplying it by 10. So 1 to 5 became 10 to 50. And then in the scan function, I'm passing it x plus y. So add all the values, add the values, and in the on next it will call the successive values it will call. So now 10, it will emit 10, then 10 plus 20 is 30. Again the same thing. And then you subscribe on it. Again, this subscribe, if you see, this returns a disposable object. So if I write this, where is ReactiveX? And let's say for some reason I don't want to use it, I can just call this dispose. So it will cancel the operation in between. Take last are quite similar. Let's say zip. If you want to see any of these, just let me know. I'll execute that. Zip, it combines two observables. Right? Yes, same thing. As we saw in the slides. So there are two observables. You were saying different types, right? There are two observables. One is integers. If you see this, this is observable of integers. This is observable of source B is observable of string, and the resultant source I want to convert into string. So what we have done here is zip source A with source B, and what is the function to zip it? Integer plus s. So string plus integer will give you strings. So now this come into source, and again the same things, the similar things: on next, on complete, on subscribe, and this is how the zip is happening. Error.
So what is the difference between skip and the filter? Because I think you can do the same thing.
No, with filter is you can specify a condition. So every item will pass with that condition, and if the output of this condition is true, it will take that item. Otherwise, it will reject the item.
Like the prime number. So you can put a condition.
You can put a prime number condition there. Yeah.
Skip was
That is one.
Skip will actually skip some items. Skip first 5 or something. In the error, I will show you the code. Let's run this first. So it emitted some items, and then it will call. It's called error, and there are actually one of the awesome things about reactive programming is its resilience. Is its ability to handle the error. So now let's see what is happening here. Because if you remember in the slides, I told that either it will call on complete or on error. It won't call both simultaneously. But see, here error is happening. This is just a string, but your -1 means error. Some error happened, and then it's calling on complete also. So there are some strategies that you can use to deal with error. Yeah. So there are 3 observables. One contains 1, 2, 3, 4. And if you remember, there is empty, never, and error. So I used observable.error to create an observable that will emit an error. That will end in an error. And then there is another observable 5, 6, 7, 8. And then I'm using concat. Concat, if you remember, that's like it will append all the observables in a sequential way. So one observable till on complete, then second observable till on complete, then third observable. It takes only 2 parameters. It's one parameter. So I've changed it here. So now this source, it should emit 1, 2, 3, 4, and then exception. And after, since exception happened, it should never print out 5, 6, 7, 8 because it's never going till there. So here I'm subscribing it, and here on error return item, there is another function. I can return this, and when on complete happens, just call on complete. In on next, just print the integer. Okay, I'll just write it. Yeah, so 1, 2, 3, 4 got printed, and on there is a function called on error return item. So when error happened, I don't want it to crash. it will return -1 and it will complete successfully. It will call on complete. The items after the error are not called. If I remove this thing, it crashed because we're not handling the error. It will say that where is it? On error not implemented exception. But yeah, before that it was working fine. This is the error demo. Yeah.
So what is so we had to stream of 1, 2, 3, 4 and then error and then 5, 6, 7. So error happened after 4, but I want to still execute 5, 6, 7. So is there any way?
No. So you can do some other things like you have to create another observable. So this error could happen. If the error is in the stream, you cannot. What is the point? If it's in the stream, if solve is giving you error. So the problem is here we are using this error, right? We're using this error. So every time there will be an error. There are methods to retry. There are methods to retry actually. Error handling I have not included in the slides, but there is error handling. So basically what it does is there are two methods, retry and one more, I forgot the name. So what it does is it will resubscribe, try to resubscribe with the observer. It will try to resubscribe and it will again get the values. And again if there is error, it will again resubscribe. So
here our observable is not crashed, our subscriber is crashed. Right. Observable will still continue.
Observable?
Will continue its own.
No. Observable, it's not working, right? It's called on error. So observable ended there. Any one question you have, right?
So my question was actually similar to his only, but in my case, supposing I need to update like a list of users, right? And one user failed with some error, but I still want to execute the rest of it. Like I still want to send them to my backend. So how do I go ahead with that?
No, see, this is a different question because you're talking about updating the users, and what we are showing is getting a list of users.
No, so I'll get it. Like supposing I'm doing from Retrofit,
Yeah.
and I have like a list of users, and I want to keep sending that. So I'm using Retrofit, and it's returning an observable for each network one.
Okay.
So after that, so one of them crashes with an error. Like suppose it times out.
Timeout exception. Okay.
After that, I want to continue pushing at least the next one.
So yeah, nobody is stopping you from pushing the elements, right? So you're pushing. You're saying, let's say 4 items, 4 users got pushed. But while pushing the 5th user, there is some error, right? So then you can retry.
Then I come back. Then I go on error, right? And then from there I can't go back to the next step. Like I want.
You can try and resubscribe. You can try and resubscribe. Error handling is not included in the slides, but there is some error handling here. Let me show you. Just one second. There is reactive manifesto. If you are not aware, this explains why do we need more reactive systems. So do have a look at it. reactive-manifesto.org.
So by default, if there is an error, it kind of disposes.
Disposes it's disposing, yeah. Error handling, yeah, catch and retry. So there are these two operators are there. There is retry and catch. So what it does is this, right? An error happens, you can resubscribe and you can still continue. So this is what your question is, right?
Yeah, but assuming that that one user will always fail. So then I'll use catch for what?
Catch is a little bit different from this. So what this tells you is, you're dealing with a list of items, some error happened, and then you switch over to some other observable. When you switch over, this does not continue from there. You switch over from a different list.
Supposing that guy miss out on that one guy is always giving an error.
Oh yeah, I know that guy.
So I can't continue the making the calls from the next item somehow?
No, so that you'll actually when you receive things like if you have done some error handling things there, like if you have implemented try catch, right? So you can handle that gracefully, not abruptly. You can do that, and plus since you're getting a callback on error also. So from there there are some backup strategies that you can use to switch it. Yeah, you're welcome. So this is error handling, which was not in the slides. Okay. Retrofit with RxJava. So you can use retrofit with RxJava. RxJava2, okay, in this slide, wherever you see RxJava, that means RxJava2 by default. There is no RxJava1 in it. So in retrofit, you have done this, right? So you create something, it will give you a call object, and then you call, what is the method? Call.enqueue. Right? You call this method call.enqueue, it will enqueue it, it will take care of background sets and everything. And then once this is done, you get a callback. So again, the callback that you get with enqueue, right? So if you want to perform multiple operations one after the other, it will still become a callback hell. And as I mentioned, if there is a phone call, right? The user has your app open. Some phone calls comes in. Your app is in the background. The phone screen is in the top, right? Or when the user presses the back button. So at that time, there's no blockage of UI, but still, since we are holding a reference to something from the activity that got destroyed, you can get like window token exception, or it will definitely end in exception unless you perform checking like if the activity is destroyed or not. So this is the pure retrofit thing, right? We can use RxJava2 adapter with retrofit. There is a RxJava2 adapter with retrofit. And while creating the retrofit builder, right, you just add the call adapter factory for the RxJava. RxJava2 Core adapter factory. You just add it, and after that you can convert this into this. So I mean, it becomes very easy to use retrofit. So after that, you don't have to call enqueue and all, because once you subscribe with it, so you don't have to call fetch user elements all the time. Also, you get the observable item. You subscribe, as soon as you subscribe, you start getting the items. So this is another thing I took from the jQuadrant stock. It was in April 2017. So now what happens is, in Android development, we write code to deal with remote APIs, to deal with remote databases, with local databases, with the UI, and that Android logo is basically, it represents the OS. So OS can also give you callback. Some phone call, some phone call is coming up, and your phone is about to go in the background. So we write code to deal with all this. So usually what happens is, I call some API, give me the list of photos, and as soon as I get the callback, I update the local database, and when that is done, I update the UI. Okay, the response is received, update the UI, and when some things happen, like Android OS is giving me some signals, I have to deal with that also. So with reactive programming, based on what we have seen today, what we can do is, we can write code that reacts to changes. So we can write code like this value changes, you update the UI. So now this responsibility is removed from the code that we write. We can update the UI based on the changes in the database. And user does something like, set my name or update my username. You can do both of these reactively. Whenever there is an API call and the response comes, so it will update the local databases. We can write code like this. And yeah, this directly interacts with the UI. So the point is, like, the code that we had written to manage all this is gone. Don't think of it as you don't have to write code. It's like serverless architecture. It's not like there are no servers. There are servers. It's just that you don't have to deal with the complexities of managing it. Same here. It's not like there is no code. The code is always there, but all you're doing with the code is you're just hooking these things, components together. So let me show you one demo. On the demo I could show later. When you're trying testing with RxJava, it provides test observer, subscriber, and scheduler. You can use this for testing, and it provides like awesome methods when you want to assert with a single value or multiple values or an observer. So testing becomes very easy with RxJava, and you already know that your creating observer is so easy. You can just call observable, not observer, observable. You can call observable.create to create manually, or observable.just to just create observable that emits one value. There are so many factory methods that will help you. So I created this sample app. The code is available on GitHub. Okay, has anyone used Dagger 2? Okay, few people. So this code is basically this sample app. Oh, sorry. Let me just project the screen. Oh no, I cannot project the screen. Whatever. I'm having some trouble projecting the screen, so I'll just do the demo in emulator as soon as it is up.
USB cable or cable?
Problem with the port, I guess. Okay, this will do, I guess. So meanwhile, when starting, do you still think that it's just a slight extension of observer pattern? It is much more than that, right? Okay, it started. I don't know why is everything black. So this is, I just implemented this API. So this is getting photos from, I created an account and I uploaded some photos. These are private, I think public photos also, public and private photos. And from this API, from the imgeo.com. So here, if you glance at it once, right, you will see a couple of things. First, these are all albums. Second, since it's public, right, so it will show you the total number of views on the albums. So this album has 2 views and 5 images. There's the Friends album. It has, I don't know what that is. Yeah, 3 views and I think 7 images. Okay, Avengers has got 0 views, and Game of Thrones 2 views. Oh, okay, cartoons, it got 320 views and 7 images. So this this app I've created using its MVP pattern. There are still some loose ends, but if you please, if you want to check it out, you can check it. It uses MVP pattern with Retrofit and Dagger and reactive programming, of course. So as soon as the page is open, it will call this API. Presenter will tell the model, get me all the images from this. So basically, it's not get because it's push based, right? This is push based. It's not pull. I'm not telling you give me the data. Push is happening because as soon as subscription is happen, the data will be pushed to presenter, and presenter will update the UI, so the view. So that is what is happening here. So now, once I click on any of these albums, right, it will open that album, and it will show me the images. So I've used some coordinated layout things here, and yeah, so it will show me the images of that particular album. That shield goes with Spidey costume, right? Very similar, right? Should not be with Captain America. And yeah, there is a filter functionality here. So if you think of it, there's 327 views. It is adding up all the views of each albums, and it is giving me total count right there on the top. It is adding up total images in each album. It is giving me a total image count right here. So now what I've done is I've used map filter, reduce, and other reactive things to create this. I'll show you the code in some time. And as soon as I start filtering, you can see the number of views and number of images got reduced based on the filters, whatever is available right now, based on this filtering. If I just say friends, okay, so there is this criteria matches with Friends and Game of Thrones. So 3 plus 2, 5 views, and it has 7 plus 8, 15 images. That's almost right. And when I click back again, so this thing right at the top is number of views, number of images. This is reacting to some events. As soon as the filter is done, the observable gets to know that okay, I need to filter something, and it filters the number of albums I'm receiving. And based on that filter, it is doing some transformation with map, and then it's doing reduce. And after the reduce, it gives me one single value, and that single value is actually a single Java object that contains two values, total views and total images, and I'm using that to update this. So you see what's happening here, right? So it's the system has become reactive. Let me show you some code. So now I'm going to ask you one question after I show you this code. That is readability question. How is the readability good, bad, or ugly? Font size? White will be good. Better? Okay. So here, let me show you where the observable is coming from first of all. There is album observable, and I will see that later. Where is this coming from? Yeah, it is coming from here. Okay, that means that data handler dot fetch albums. Yeah, this is giving me the list of something called Pixie album. That is the model that I used internally here. That is a model used here, and this gives me IMG or related Pojo. This gives me some other related Pojo. This gives me something else. So I'm just transforming it into this type of observable, that is the Pixie album, and using that. So by the way, because it's MVP and the logic is in the data layer, in the model layer, right? So this is simple logic that if network is available, get it from the network. If network is not available, get it from the local database. I'm using my object box as a local database. It's still in beta, but yeah, it's good. It's worth checking out. So here, let's say network is available. So what we're doing is we're calling the mjor API and fetch user albums, and it's passing some header and some username, and it gives me an observable of this user albums. Yeah, here. As I mentioned, since I'm using the RxJava2 adapter, I can write observable here. So now based on some authorization and username, it is giving me the observable of this object. This is specific to the imager side, right? So now, if you want to see this thing, every service has its own customization, right? So if you see this Pojo class, so it gives me a status, and is it successful or not, a boolean. And in the data field, it gives me the entire album list. Let me just show you the API here. Oh yeah, this is the one. So if I'm calling this API and it's giving me success and status, and all the albums, the user albums are inside this, the details of the album. Just the details of the album. There are no photos here. Right? So now, if you look at this, this is one object. And if I use observable, I could have used single also. Right? I can use single also because essentially there is only one object. But what I want to do is I want to use the good operators of reactive programming. Right? So I cannot use it in one operator. So what I did was I transformed this observable, which emits a single item, into an observable that emits a list of these albums that is inside the data point. So now, yeah, this will give me an observable which emits this. I use flat map here. If you remember flat map, what it does is it will take each item from the input observable and it will use each item to create its own observable, and it will flatten everything and it will give you one observable that emits all the values from all the observables. So since we have got only one value here, so what I'm doing is I'm getting this, and yeah, it is giving me an album list. Right? It has an album list because that's actually the data part. So it is giving me this. I'm just returning it. So now basically all the items of the album it will give me in a form of observable. So now I have got an observable of the user albums. This gives me what? Yeah, the album, not the user album. User album is something that contains all the albums plus the status plus the boolean success, and this contains only the data part. I converted into an observable of this item, and now I'm mapping it. Now, as I mentioned, it has, this is the this is the Pojo that is giving me. I don't want to use it, so I converted this into something that I will use internally. This is Pojo that I created. So if you look at this map, what it's doing is it's taking one album, and there is an adapter I created. So you pass in the imager model, it will return me my model. So now I got an object of this created using this. And then here, this is the database thing. What I'm doing is I'm saving this data in my local database. Save it in local database, remove it for remove any duplication is there, and I'm using buffer here with a fetch size of 20. I'm using a buffer. So now, if you look at it, every time somebody calls fetch albums, every time anybody can call fetch album, right? There could be photos in the first page and some other page, some management page. So anybody calls fetch albums, this will update my local database. And if the network is not there, it is reading it from the local database, converting into the same type of observable, and it's returning. So the presenter what it does is it will call fetch albums. It will call fetch albums. Presenter does not know the data is from local database or from REST APIs from there, from the server, and it gets an observable of list of Pixie albums it received. So this is the observable creation. I'm using observable.create here, if you notice. Oh no, not creating it. Retrofit is giving me the observable. Now once this is received, I want to process each album, so I can extract out the cover image, so I can show the cover that you're seeing, the album cover. And also what I want is the number of images an album contains plus the number of views. So now if you look at this, so now we got an object of album observable. Yeah. Now just look at it, how it increases the readability. Album observable. What I'm saying is subscribe it on schedulers.io. Basically, IO bound threads for asynchronous operations. Everything written after this will happen in asynchronous manner. some error happens, just print the stack trace observe on, and here after observe on, I've written Android schedulers of main thread. So everything written after this will be on main thread. So just looking at it, you know, okay, this will happen in background thread, this will happen in foreground thread, right? And yeah, I'm also using compose. So compose, what it does is it transforms observable from one type to other type. Now here essentially it's similar. Oh no. So it takes an observable of pixie albums, it gives me an observable of stats holder. The stats holder is the class that is holding number of views and number of images. So it gave me an observable of this. I mapped it, and in the map I'm creating this stats folder and returning it. So now after this map is done, it will give me an observable of all the observable of this stats folder, and I'm reducing it. So reduce is based on what? Just setting the album ID, setting the number of views, adding the number of views here, and adding the number of images here, because I want to show total number of images and total number of views. And after reducing it, I'm just just returning that. So where is this? Okay, compose. So this will apply map and reduce. It will give me the reduced. Give me what? Reduced from the statistics of the user albums. Then I've written observe on main thread, because this will, I think, switch down to computation thread. Yeah, we're switching to computation thread. So everything written after this will happen. This map and reduce will happen in a computation thread, and this is a very handy method, because reduce will give you a maybe. Right? I showed you. Reduce will give you a maybe. It can contain one object or it may not contain one object, and you can just call maybe the two observable. It will convert it into observable, and that is a requirement for the compose method. So we did that. Okay, so now once you have the stats, I can just call subscribe, and this is subscribe. This takes a consumer, I guess. Yeah, consumer. Yes, which just takes whenever there is a one value thing, right? So in RxJava we use consumer. It will give me the stats that was a resultant of this operation. This operations. This is the stats holder, and yeah, I'm calling view.update stats with the actual statistics. So now, just after looking at this, perform the, because we're subscribing it on schedulers.io, so perform all the retrofit and other operations in the background thread. When some error happens, you want to handle some error, you can handle the error here, and observe on main thread, because we are what we're doing is we're updating view, essentially updating view here. We're passing the album list so that the view can get the data and render the image based from the URL. So that we're doing in the main thread. After that, we're converting from this to iterable. We're converting into iterable. This is actually, this should give me a observable of single albums. But since it's not giving me, I'm converting into, from iterable, I'm converting it into this album. Composing it and observing on the main thread and this. And now this gets more interesting when you look at the filter thing. If you look at it, it looks complex, right? But it's so easy, so readable. Here we are saying is, search observable. When you start searching, it will call this function. Subscribe or schedulers.io. So do perform the operations in the background thread. So this is on complete and on error. Filter it based on the text that I'm entering in the text box in the search box. Filter it, and this is my condition. So for filter, there's one condition, we have to return true or false. So if this album title contains the word, or description contains that word, or the provider contains that word, you return as true, otherwise return false. And then when we have to update the view, we are saying, observe it on main thread. So frequent thread switching is happening here. Initially, it's on the background thread. Then do all this, and after this update on the UI thread, then this compose will actually switch to computation thread, and computation thread will compute all the total stats of the user albums, and then we'll again switching back to main thread, and then we're subscribing and we're updating this. Right, so let me just show you this thing.
Does do uncomplete get called when you press enter? When it loses the focus.
No, on-complete is called, like when you're using retrofit, right? So it is giving the observable. So it is calling on-complete when the data is done. And when, in this example, when I'm using the local database, the network is not available here. I'm calling the on-complete myself here.
But in search, when you are searching, so when you have data already, you're searching.
Hmm.
There's a point in time when you can say that okay, now
So on-complete will be whenever the search, when search is done, right? So I'm looking for, I'm typed F. When I typed F, it will give me all the albums that starts with F or contains F or whichever matches the condition. It will call on-complete after that. I type FA, it will again do the same things. It will call on complete. You can change this according to your requirement. Okay, what I was showing you. Yeah, here I'm printing it. I'm printing the thread name. Okay, so let me do the search again, and we'll see what gets printed. Okay, so I'm just typing one keyword. So you can see what is happening here is filtering is happening in some scheduler, some cache scheduler, and updating the album that is happening in the main thread. MapReduce is happening in the computation thread, updating album in the main thread. Again, MapReduce in this. So we are switching between threads so easily. I never knew this was possible. Just write this. Whatever is written after this will be on the main thread, unless it encounters another observe on. Like right here is another observe on.
So compose will be by default performed on the computation thread.
The compose.
That will be on a computation thread by default.
No, it will not be in computation thread because since compose what it's doing, it is just transforming the observable. I've written here computation thread. I can remove it, so it will do it whichever the thread was there earlier, right? It will do that. So this is filtering, and one last thing I want to show is okay. I cannot show it from this actually. I need my device.
You want to give us all?
It's because this port is not working, and this port is actually currently busy on recording purposes. So when you open an album, there is a this is I've also added a functionality to upload photos. Okay, I'll upload from here and then I'll show it there. Because I cannot upload from the Genymotion, I don't know, some issue. So I'm uploading in this album, the API album I'm updating. Okay, so while it is uploading, there is here. By the way, do you know that you can use Retrofit to upload images also, not just REST API calls, strings and all. This is the code I wrote to upload the image. This is specific to this service. It requires title, description and all. Okay, it says album upload successful. Okay, now it's showing 6 images. It was 5 earlier. This is the image. This is the image I uploaded just now. So in the upload things, what happens is like his example was there, right? He said we want to say process a list of users or we want to upload it, right? So now this is happening here, and it gives me. Let me show this thing. This is the image upload. This is the image upload API. You choose the file, it will upload it, and I chose a file and it gave me this response. So it is giving me the data of the image that got uploaded with success and status that is fixed for this API. Success is true, status is 200. Now, if you want to update it, update something based on the status, then you can use this. If you don't want to do this, what you can do is you can use completable. Completable source, what it does is it will just tell you if the operation completed successfully or failed. You can use that. I'm using a single because it's giving me a single value. So you can use that as well. So that was testing. Demo is done. So that's all I had for today. Thank you guys. Any questions you have? Thank you. And the demo app is available here, so you can. I'll be making some more changes in it, but yeah, you can watch it. Yeah.
When you are saying you are mapping object of imager album to pixel album, so do we need to handle those mapping explicitly? I mean, for example, there is a field for the image album like image URI, and in our pixel there is some URI, for example. So do we need to handle those explicitly?
That we have to do because I mean, otherwise, how Java or RxJava will know how to convert this into this, right?
Okay. So we can use, for example, like we have told earlier, there is one imager, the other source will be Flickr. So again, the same way we can do the mapping. Right?
Yes, same mapping. So Flickr has some other Pojo class, right? So it has a different structure and all. So again, you create a adapter in between, and you convert it into your type that you want. So in this, what is happening is this is actually kind of very generic. It will tell you which it belongs to. It belongs to this service. So in this, what I've done, I'm telling you, this Pojo class, this knows which service it came from, what is the username of that service, because user essentially logs in, and the URL, the cover, the number of views, the number of images in the album. So yeah, so you can basically map this with everything. Right? Yeah.
So in this, you have used Retrofit to connect your server. So it is also needed that your backend should be also reactive.
No, not mandatory. So the question he has asked is, if I'm using Retrofit in the client, does the backend also need to be reactive? That's the question, right? That's the question. So answer is no. But yeah, I mean, you can use that separately, but it's not mandatory. It's a regular API also. You can make your client system reactive.
Okay.
Yeah.
So how this systems actually work? I mean, if I upload to this backend from some other device, and you are getting a call in your client that okay, something is uploaded in the system. So how this thing works and how the connections are being.
Okay, so you're saying your question is how does the client get to know that something gets uploaded?
Yeah.
Yeah, no, that doesn't happen. That will not happen. If something changes in the remote server, our client will not come to know, okay, something has changed. Magically, it will not come to know.
Right. So
Unless you're using some sort of say push notification service or some sort of polling, it will not come to know that. Right? So, in the example that I showed you, right, if you remember that Android things, right, the remote server changes and it will update the local database.
Right.
So that will not happen automatically. If there is some API that is calling, so I'm using an API that is getting some data, updating the UI. So one of the side effects with that API is it will update the local database.
Okay.
Whenever that remote database changes, it will not give me a call back. Unless you're using things like that. And especially, I mean, I've not explored it much, but if you use it with architecture components, there is something called live data. It's awesome. This will give you some changes. Live data will actually give you the changes. Okay, this has changed. What is the change? Yeah.
The same thing was in Realm library. If the local database data is changed, will get updated in UI library.
In Realm also, right? Yeah. In Realm there are some things like that. Realm has become much more than the database, right? It's become an entire mobile development platform.
Realm has also extension functions like as an observer. So your query gets written as an observer also.
Okay.
Suppose we see with this example. So if you are in Realm with this example, you just need to query and just use the add observer. You get automatically that query observer.
Oh, you get a query observable, right? With what?
With Realm.
With Realm you
Yeah.
okay. Okay, nice. You use Realm. You can use Realm also.
Yeah.
Even Green
Yeah.
now supports that.
Yeah, GreenDAO. This what I'm using is GreenDAO. It's my object box is from GreenDAO. So in your feedback form, please write next meetup suggestions. And here are some if you want to some idea. You can write this or you can write your own suggestions. We also have a Slack group. So if you are not a part of it, you want some invitation. So please mention your email address also in the feedback form. So I'll send you an invitation by today or tomorrow.
Since you can, with the operator, you can modify the data streams. So I think the advantage here is you can also use it when you're using some data science operations. You can filter out, data and then sort of things.
You can filter out data also. Yes, probably so. Yes.
So in data science operations or in IoT kind of applications.
I understand. So I mean, I'm not a data scientist, but yeah, you can use it there also. Because since this is everywhere, right? RX Python is there. You can use RX Python probably with I think it's called NumPy and Pandas library for data processing and these things, big data things.
How different is it with data binding? What we see is that observer will observe some change in model and the data binding thing does the same.
Data binding, yeah, I mean, like you're talking about MVVM sort of thing. Yeah, so it binds the data, right? So it will just, if the data model updates, it will update the view, right? That's what you're talking about, right? So difference is in this is not just one thing, right? It's a broad concept. It's in a lot of things. It's not just about updating the data. It's about adding side effects and resilience and readability. So you can use this with MVVM as well. So transferring data from the source of the data. From there you're updating the model, the view model. For that you can use retrofit, not the retrofit, reactive programming. These are some references that I used. If you're serious about learning RxJava, I'll share this. So these are some good resources. There's too much to note, like, so I'll just share this PPT. And before you leave, there is a snacks outside, so please have them before leaving. And if you have not related to this, if you have any other questions, we in meetup. So how many of you are actually coming here for the first time? Okay, a lot of you. So what we usually do is after the meetup is done, we usually as a community we try to solve some issues that you have, not necessarily related to the meetup that we're having. So if you have any questions, you can ask, and the rest of us can gather, and maybe we can try to solve your issues that you have. You're facing maybe.